Welcome to Chapter 8 of Class 9 Science, Force and Laws of Motion. In this exciting chapter, we'll discover what causes objects to move, stop, or change direction. We'll explore Newton's 3 laws of motion that explain everything from walking to rocket launches. Get ready to understand the fundamental principles that govern all motion in our universe. Let's begin with balanced and unbalanced forces. When forces acting on an object are balanced, they cancel each other out and the object's motion doesn't change. But when forces are unbalanced, they cause acceleration. This explains why a heavy box won't move with a small push. Friction balances your push, but starts moving when you push harder, creating an unbalanced force. Understanding this balance is key to understanding all motion. Now let's explore Newton's first law of motion, also known as the law of inertia. This law states that objects naturally resist changes to their motion. An object at rest stays at rest, and an object in motion continues moving with constant velocity, unless acted upon by an unbalanced force. The coin stack experiment beautifully demonstrates this. When we quickly remove the bottom coin, the upper coins fall vertically because their inertia makes them tend to remain in place. Let's discover Newton's second law of motion, which gives us the famous equation F equals ma. This law tells us that force causes acceleration, and the acceleration is directly proportional to the force and inversely proportional to the mass. A small force on a heavy object produces little acceleration, while the same force on a light object produces much more acceleration. This law also introduces momentum and explains why fielders pull their hands back while catching balls, to increase the time and decrease the force. Now let's examine Newton's third law of motion. For every action, there is an equal and opposite reaction. This means forces always come in pairs. When you push on a wall, the wall pushes back on you. When a rocket expels gases downward, the gases push the rocket upward. The key insight is that action and reaction forces always act on different objects, which is why they don't cancel each other out. As we conclude this chapter, let's review how Newton's 3 laws work together to explain all motion around us. The first law tells us about inertia, the second law quantifies how forces cause acceleration, and the third law reveals that forces always occur in pairs. These laws help us understand everything from vehicle safety to sports to space exploration. They form the foundation of classical mechanics and remain among the most important discoveries in the history of science.